Bismillah ar-Rahman ar-Rahim. Let's start with each other. Today we'll completely talk about potential energy also, but today we have another kind or another form of potential energy. As I told you before, we have different forms of the potential energy. The energy we have today that is called elastic potential energy. Okay, look over for this spring, for example. If we converse or stretch this spring will move. Okay, now why this spring have kinetic energy or have movement? Because of the potential energy stored in this material. Okay, when we convert or stretch it, we have motion and we have energy come because of this potential energy stored in this spring. Okay, now any potential energy stored in any object come because of the elastic or from the flexible of this material. We have elastic potential energy. Okay, now this potential energy come from where? Come from this material. This material have some flexible materials inside this one. Okay, because that we have a lot of examples. You can see that every day shows you the elastic potential energy. For example, guys, here look over for this rubber band, for example. Also, this rubber band have elastic potential energy stored in this material. Okay, if you hold it and stretch it like that, this one can move from place to another place. Why? Because of the elastic potential energy. And we have a lot of examples. Look over for this guy, for example. Here we have rubber also and arrows. Now the arrow can move. Why? Because it's stretched of this rubber band. And now this one can move in this direction. From where get this kinetic energy? From this rubber band, from the elastic potential energy. Okay, and also this dog or cat play in this place also have these place have also elastic potential energy. That is the different kinds and different examples of the elastic potential energy. خلاص يا شباب. Read please.
Okay. Elastic potential energy, the energy available for use when a deformed elastic object returns to its original configuration.
Excellent. Okay, now the elastic potential energy come from where? Come from the object elastic, the object flexible. Okay, and for example, a spring, for example. Okay, when we converse this spring, okay, and release it away, now this spring will move up and down. Why? Because of this spring made up of elastic material, elastic object. Okay, and this object can return again to become in the original state again, and we will explain more by some experiments and some we have some examples also more about that. Okay, I have also simulation to explain more about that, and we have a lot of things to explain today. Okay, but today we will focus on the spring. Okay, that is called the spring. Of course, most of you know the spring. That is called the spring, guys. Okay, and we have object in the end of this spring, and this spring holds in the wall or holds in the place to be start with rest. Original configuration or rest and like that. That is our example I will focus on today. Now let's explain more about the elastic potential energy using spring. Okay, now look over, guys, here for this picture. Now we have here object holds with this spring. Okay, this it was in this place at the beginning. Okay, it was in this place. Okay, now when this object start in this place, okay, this distance is called relaxed length of spring. It means the original state of the spring. We do not make anything yet. Okay, when we conversed this spring, it will make distance. The distance from this the spring conversed till the original part, that is the distance of conversed. Okay, I will explain again and again and again. Don't worry. Okay, now look over for this simulation also for this diagram. Okay, now that is the original state. That is now we do not have any applied force. I don't converse or stretch it. This case now the length from here to there, this length is called relaxed, okay, relaxed length. What the meaning of relaxed length? Relaxed length, it means the distance from the wall to the object without any movement, the original state I mean, okay, the original state I mean, okay guys. Now when I stretch it, I will make distance. When I converge, I make distance. That is the distance we will talk about now. Okay guys, and also guys, I have simulation to explain more about that, don't worry. Okay, now here that is x. I will explain about that now. Okay, now this x or this energy depends on the distance of springs converged or stretched. What does it mean? It means when you stretch it more, suppose that I will hold this spring and I will move it in this place. Of course, the energy will be more than if I stretch it like here. Okay? Again. Look over. Suppose that I have two cases. I will use this spring to stretch it. Okay? Now, in the first case, I will stretch it up till here. This is the first case. In the second case, I will stretch it up till there, like that. Of course, the energy here will be more than the energy there. Why?
And the distance will
yes,
increase
because
also.
more energy and more stretched. It means, guys, when we have more x, we have more energy. When we have more x, when we have more stretched, we have more energy. The same thing with conversed, guys. The same thing with conversed. Most important point, guys, to understand that the relaxed length. The relaxed length, it means the object do not have any applied force, any movement. That is original state. Okay, we do not make anything. That is the relaxed length. Okay, now let's complete about the formula or the equation of this one. Okay, now the formula of elastic potential energy. Now elastic potential energy equals half k x squared. Okay, now focus in these parts, guys. Now here be elastic, it means elastic potential energy and measured by joule, of course. I told you before, now all the forms of energy measured by joule. We do not have any problem for that. Okay, leave this one now. I will speak about that because it's very important. Okay, now x here, I just explain it here. Now distance of conversed or stretched. Not x here, not the relaxed length. No, x here it will be the distance for conversed or stretched. If we come back again here, okay, look over here. Now this is x, guys, from the 0 point to stretch point. That is x. Okay, it means if he gave you in any problem, he gave you all the length from here to there. He said that from the wall to stretch it will he will make for example 10 or 30 centimeter. Okay, 30 centimeter. Now all of these are 30 centimeter. And he said that this object or this spring start from 20 centimeter. It means the stretched length is just 10 centimeter. Okay, because we should understand what is the length of stretched or what is the length of conversed. They are the same x. Okay, guys. And please be more concentration with me to explain K because it's very important. Okay, what is K? K here is spring constant. K here is called spring. Okay, spring constant. This spring constant depends on what? Depends about a lot of things. At first, depends on the material. You will make this spring from what? This spring made up of metal. Made up of aluminum, made up of plastic, made up of what? Okay, now the material of this spring will exert for all the elastic potential energy. Okay, this is the first point you should understand. Okay, and also this spring material, if this spring material light, not really strong, okay, you can stretch it easily. Okay, you can stretch it easily. But if this spring material or this spring material stuff strong, okay, you cannot stretch it easily. Okay, guys. Now this K is spring constant. Which material we made? We'll made this spring from which material? This material, light material, like plastic, like anything else, light, not really strong. If this material is strong, like iron, like another materials, very strong, this stuff material, okay, you can't make a lot of applied force with a strong material. Okay, guys, like the spring of cars. Spring of cars uses in cars, so very strong. Okay, to take this any action you made by your car and like that. Okay, that is the first point for the spring constant material. Okay, now this is K. Okay, now as you see here, K is constant. It means most of time he will give you on the problems. Okay, because it will be different from one material to another. Okay, it's guys. Now let's complete to take the definition of the spring constant. What is the spring constant? Okay, this is very important also, guys, to understand and to memorize. Okay, I want someone to read this. Excellent. Yeah, this is a very amazing definition to understand about spring constant. Now he is speaking about the material of the constant. How much this spring will resist the compress or stretch it. It means that this material made up of what? Plastic, copper, aluminum, iron. Okay, now it's a barometer that is measure the spring's resistance. Okay, it will measure how much this spring resists the compress or stretch it. Look over for this simulation, guys. That is a spring. Okay, and here that is the constant, spring constant. Okay, now and that is the applied force. Look over, guys, here when I make applied force like that. Okay, and that is the distance. That is the distance of the of stretched. Okay, now when I move the spring constant more, look over. Now the applied force, the applied distance, applied force, and the distance will be lower. Why? Because now this one becomes stronger. This one becomes stronger. Okay, and the distance will be lower. Now this constant will be higher, and this constant spring of spring will resist the applied force more. Okay, by this way you can understand that spring constant, when we have more spring constant, the applied force will be lower and also the distance will be lower, and this spring of constant spring, I mean, it will resist more for all the applied force happen for this spring. Okay, look over when we move it more. Okay, the distance will be lower. Why? Because you cannot make more applied force, because now the spring become more stronger. Okay, and the opposite is right, of course. Okay, Shabab. This constant measured by Newton per meters. Newton per meters. That is the unit of K. K, the spring constant. Okay, from where we get this Newton per meter, it's a very long thing to explain it. We have another formula called Hooke theory, or like that. It's a long time to explain it. Anyways, that's K, spring constant, measured by Newton per meters. Okay, now let's move for the problem, guys. Now here in this problem, okay, yeah, that's the relaxed length. That is the relaxed length. Okay? That's the relaxed length. Okay, now here that is relaxed length. We can say that x relax, okay, equals 15 meters. Okay, complete Hatim, please. He jumps off
a bridge spanning a river from a height of 50 meters.
Excellent. Okay, guys, now the bridge height is, now this is the bridge height. Okay, the bridge height from the river, that all the height for this bridge is 50 meters. Okay, I will write some things and I will draw another things. Okay, to explain more. Yes, complete Hatim. When he
finally stopped, the cord has a stretched length of 44 meters.
Excellent. Now he stretched. Now he hold himself in this cord, and he stretched this cord up till 44 meters. Okay, 44 meters. He don't reach the river. Okay, just 44 meters. Okay.
يعني ربط حبله نفسه ونزل
Yes.
تحت لحد 44 متر.
Yes, 44 meters. Okay. Yes, complete حاتم تفضل.
Treat the stunt man as a point mass and disregard the
Disregard.
weight
Yes.
of the bungee cord.
Yes. Yes. Assuming complete.
Assuming the spring constant of the bungee cord is 71.8.
Okay, guys. Now this constant is K here is equal 71.8 Newton per meter. Okay, look over for this unit. That's the unit of the spring constant or cord constant. Okay, yes, complete. What is, yes?
What is the potential energy relative to the water when the man stops falling?
Okay, thanks a lot, my dear friend Hatim. Okay, look over, guys, here for this problem. Now I'll open my board. Just he asked you about the total potential energy. It means he wants two things. He wants the potential energy, gravitational potential energy, and also he wants the elastic potential energy. Elastic potential energy. Okay, elastic potential energy and the elastic elastic. Okay, elastic potential energy and gravitational potential energy. Excellent. Look over on this drawing. Okay, now he give you what? He give you the stretch of this one, and he give you the relaxed length. It was 15, like that. Okay, now about the potential 2. Now the first thing, we will find the gravitational potential energy. What is the rule of gravitational potential energy? BEG equals mgh. That is the formula. Okay, mgh. That is the formula for gravitational potential energy. Okay, now how much h we have here? Now the h, it will become from, look over, yeah, from the river to this height. Just this.
وعايز انهي اتش يا مستر؟ اتش من البريدج ليه؟
Now h here, guys, h here, it will become 50 negative 44 equals 6 meters. يبقى now h here it will equals 6 meters. Okay, now by easily way we can find m. You have m and g. Of course you memorize g, but I will make it all of them at the end. Okay, let's complete. Okay, now number two, we want to know how much the elastic potential energy. Elastic. Okay, elastic potential energy formula is half k x squared. Don't forget squared, please. Don't forget squared, please. Okay, I said that at the beginning, guys. The x here, that's a stretched point. Now he stretched, how much he stretched? Now from 15 to 44. It means x here, in this case, it equals 44 negative 15. Okay, it equals, guys, 29 meters. 29 meters. Okay, now we have all of things. Now we have m, we have g, we have h, we have half k, x, and we will make add all of them and find the total potential energy. We have just substitute 70 times 9.8 times h here 6 meters plus we don't write meter. Okay, plus half. Okay, k, he gave you k, that is 71.8 times x squared. Don't forget squared. Now x here is 29 squared. Okay, don't forget square, please. Equals, by calculator, this number 3224.9.8 joule. Okay, now that is the all of this number. We can make it by this way. We can move this comma here, 1 2 3 4, and like that. 3.3 times or 3.2 times 10 power 4 or 4 joule. Okay, that is the answer. At the end, guys, I hope you understand this problem and the other problems approximately the same. Be careful about the relaxed length for the distance and like that. And be careful what he asking about. Ask about elastic potential energy or gravitational potential energy, and it will be easier to answer all the problems. Thanks a lot. I hope you understand. If you have any problem, ask me in WhatsApp or down in the comments. Thanks a lot. See you next time. Inshallah Rabbil Alameen. Assalamu alaikum.